Segment 3 of Chapter 8 begins by finishing up the discussion on cortical maps. So it talks about their plasticity and how they can change with experience. Then the chapter goes on to talk about pain. So pain is defined as discomfort normally associated with tissue damage, and it's both a sensory and emotional experience. Congenital sensitivity to pain is a condition of being born without the ability to perceive pain. Pain provides us with a powerful lesson about how to avoid injury. 3 ways pain is helpful is that short-lasting pain can cause us to withdraw from a source that might prevent further damage. Long-lasting pain promotes behaviors such as sleep, inactivity, grooming, feeding, and drinking that promote recuperation, and expression of pain serves as a social sign to other animals. Human pain can be measured, so learning, experience, emotion, and culture all affect our perception of pain. Peripheral receptors get the initial message when we do feel pain, so in most cases, initial stimulus for pain is destruction or the injury of tissue adjacent to certain nerve fibers. The damaged tissue releases chemicals that activate pain fibers, so nociceptors are neurons that respond to stimuli that produce tissue damage or pose threat of damage. Free nerve endings are an axon that terminates in the skin without any specialized cell associated with it, and that detects pain and/or changes in temperature. Capsaicin is a chemical in chili peppers, so it's a compound synthesized by various plants to deter predators by mimicking the experience of burning. Transient receptor potential vanilloid type 1, or TRPV1, is the receptor that binds to capsaicin to transmit the burning sensation from chili peppers and normally detects sudden increases in temperature. The reason chili peppers taste hot is that the capsaicin in the peppers activates TRPV1 receptors in the body that normally detect noxious heat. Transient receptor potential type M3, or TRPM3, does not respond to capsaicin, and receptors are found on the nerve fibers larger than those carrying TRPV1. Receptors found in some free nerve endings that open its channel in response to rising temperature. Cool menthol receptor 1, or CMR1, is a sensory receptor found in some free nerve endings that open an ion channel in response to a mild temperature drop or exposure to menthol. It's also a member of the TRP family, but responds to cool temperatures and is found on small C fibers. Some free nerve endings provide sensation of itch, so some of these free nerve endings respond to histamine, but some are histamine independent. Both itch systems use the TRPV1 receptors. The book talks about a boy in Pakistan who felt no pain, and they found that 6 of his family members also felt no pain. So they found that the gene SCN9A was mutated in this family, and it was responsible for the pain insensitivity. They found that this gene encodes a voltage-gated sodium channel called NAV1.7 that is expressed in many free nerve endings. So pain receptors rely primarily on this channel to spark action potentials and cause the feeling of pain. Other mutations in this channel can result in the opposite, and people can have chronic pain.